I will never, I will never understand the people on Channel 6. Oh, man. You know, kind of the point of two-way communications is to actually communicate some type of information. I've never figured out what they're communicating. It's not the weather, not general conversation. They're just blah, 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 blah. Bye, 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 bye. It's all they do all day long. Oh, any case, sorry about that. If nothing else, Channel 6 is good for a laugh just listening to it. So today on the bench we have a Courier Centurion 40D. This one was sent in to have restored. Now, it's had a lot of work done to it. It's in really good physical condition with a few exceptions. For starters, it's got a hole drilled in the top cover because it had this rotary switch installed in it. As you can see, the Clarifier Knob on this thing is massive. It's that huge one right there. It's supposed to be a little small knob like this. It may look goofy, but in reality, that actually makes it easy to use the clarifier. So if I had to take a guess, whoever used this radio was a big sideband talker. Of course, the bigger the knob gets, the easier it is to do fine-tuning control. Now, you know, of course, you could stick a 10-turn clarifier in here, but back in the day, and I would have to say all the work that was done to this thing was done back in the day. Just looking at this channel modification for starters. So yeah, 10-turn potentiometers were really, really expensive back then. You know, nowadays, people get cheap ones from China, yeah, a couple dollars, bam, you're done. Back in the day, this was an easy way to get I don't want to call it fine-tune, but it made it easier to tune in because as the diameter of the knob gets bigger, it's a little bit of movement. It's almost like making it fine-tuned. You got a little tiny knob. It's really hard to do fine-tune adjustments. The bigger it gets, you know, you have to remember you're on an arc there. So that little tiny movement down here spreads out at an angle. So a lot more rotation means less movement at that little knob there. Yeah, other than that, the front's in good condition. Like I say, it's got some pencil or pen marks on there. I guess I haven't even checked alignment yet, so I don't know. The top cover, like I say, has got a hole in it. The channel modification is definitely old school. Let me just turn it off here to get rid of that internal light. So what they have here is a rotary switch stuck in the top. Now, there's nothing new about rotary switches for channel modifications. Usually they'll just have the rotary switch attached straight to pins on the PLL chip, so you'll cut the trace and they'll have the switch wired into that circuit. They didn't do it like that in this. They did it. It's a little bit better design, a little sloppy the way it might have been done, but it works, and it's a better way of doing it, I guess you could say. So in this case, they have the rotary switch. They have a diode matrix. This was a sticky, gooey mess because this thing had been taped up in several layers of black tape, and then this glob of goop you see down there is silicone. They then had this glued to the inside edge of the radio. But this is a diode matrix board, so that's all it is. And it's a little flexible board too, really, really thin. Like a couple sheets of paper thin, really flexible. But yeah, that's what they use for their diode matrix. And then that runs down to this little circuit board, which has, we get zoomed in here some. So you can see there's actually an integrated circuit right here, okay? And this is an early integrated circuit. Yeah, you're probably used to, the little black centipede-looking ICs. This is an IC too. It's just in a little metal can instead. Back in the day, those were actually kind of popular. And you even find, not this IC, but you'll find ICs like this in some early CB radios. But that's how they did the modification. There's a lot of other stuff done to this. I really need to contact the customer and see exactly what all he wants to do to this. He said, you know, basically set this one up like it was your own, Mike. Yeah, there's a lot of stuff that needs to be done to this. For starters, it needs to be recapped, which he wants done. Wrong direction. I zoomed out, not in. The biggest problem with one of these is, honestly, they are a pain in the butt to replace the electrolytic capacitors in. It is, let me just turn off my power supply over there. Let me get this thing set back down, level on the bench. Just get everything unplugged. Move the microphone out of the way. Actually, I'm done. Yes, there's a meter lead attached because I actually had to do some repairs here to get it to turn on in the first place. Okay, now let's get repositioned right over top of it here. Okay, so this is a unit in board. It's a variant of, it's probably the best way to say it. It's a variant of the popular UPD 858 chassis. If you look at it, it looks really similar. So, you know, if you were to crack open like a Cobra 138 or 139 XLR, you would see something that looks very, very similar to this. But it's different. For starters, this has a can, a big sheet. Now, granted, it's got this little circuit board glued to the top of it, but it has a metal can here. In the normal UPD 858 chassis unit-in radios, which were used in a lot of radios, they don't have this can. All the components are mounted down to the circuit board. It's not like that in this. This one, if I can get this thing pulled up here. Got all these extra wires to contend with. So this actually has a separate circuit board. The circuit board that you see inside of there is not the main circuit board. It's actually a little circuit board that's attached to this metal can, and then this metal can has a bunch of mounting ears, and that's mounted down to the circuit board. So, yeah, it's tricky to work on anything in there. Replacing any component on that, you have to remove this entire module to get to the bottom side of it, to get to the, you know, the solder side. Don't want to move stuff around here too much, so I don't want to go breaking any of these wires off. It'd be a nightmare trying to figure this back out. But like I say, you look at it, basically same setup, you know, relays. Like I say, it's pretty much the rest of the board is almost a carbon copy. There are some differences in the way the RF final sections, some of the layout over here. Same components pretty much, it's just the layout's a little bit different. Relay, this does have a SWR bridge board mounted here on the side of this heatsink. Yeah, and it needs a lot of work. I really got to go through this thing with a fine-tooth comb. There's a capacitor here glued to the top of this capacitor, and it's goes to a wire. Yeah, that's got to be something, some type of audio mod. There's another electrolytic capacitor here. It's looks like same vintage, but like I say, this is probably done. All of these mods were probably done back in the day when this radio was new. Yeah, this definitely is not factory, though. It's bodged across the resistor here, so yeah, I gotta see what... and it overmodulates, definitely. I can just see that on the watt meter. When I give it a whistle, it's well over 15 watts, so yeah, somebody's trying to let the smoke out of it. I can see the coil right here is spread... yeah, they couldn't spread it apart any farther. So that, yeah... it just needs to be gone over. The light bulbs look like they've all at one point in time have been changed, because all of them have heat shrink tubing. You know, here, all of those were replaced at some point, and those and those. This one was actually just laying in the radio. It's got the black silvery look. That's about as burned out as it gets. But yeah, even it's been replaced at some point. So this is a high mileage radio. Now the first thing the customer complained about was the power supply didn't work in this. Actually, it did. The problem was And he also said that the clock didn't work. Actually, the clock did work. Now, I'm assuming he powered this up with an external power supply, because this has a DC power jack on the back, actually, that takes a normal power cord like this. And he powered it up with that. But I guess he assumed the clock didn't work. The clocks in these are 120 volt. So unless you have this radio plugged into a wall outlet, the clock's not going to work. And actually the clock was the problem with the radio, why the AC power supply wasn't working properly. Actually the power supply was working. The problem is the red wire right there off of the power supply board, that's actually the voltage out. That wire comes down through a piece of this fiberglass tubing here and comes up to this little, let me position here. That wire comes up and goes to this little micro switch right here. The clock has an alarm function. So you could set this thing to, wake you up in the morning. So if you set it for 6 o'clock, you can set it for either the little buzzer alarm, which is actually this little metal arm right here. It just buzzes. Or you can set it that the radio will turn on at whatever time you have the alarm set to. Well, it does that. The power supply in these is on all the time. Anytime this radio is plugged into a wall, this power supply is always on. This is what actually turns the power off to the radio. Well, I mean, it has the on-off switch on the front. But if you turn the on-off switch on and you have the clock set to the alarm function, the radio won't actually be on. That's because it breaks the circuit, because the output from the power supply goes through this little micro switch, and it has, you can see that when I push up on it, that would be off. So right there would be off. I can push the on-off button on the front of the radio on and off all I want, and the radio is never going to turn on. It would trip like that, that would flip the radio on. And then if you just put the knob on the front of the radio to the on position, then this switch is left in the on position all the time. That's actually what was wrong with it. When you plugged it into the wall and you hit the power switch, the 2 light bulbs inside the clock, when the radio was off, were nice and bright. Now, granted, the display in there is so just dirty, just heat rising up and dirt collecting on the inside of the lens. You can barely see the actual clock display, but the light bulbs light up really bright. The instant you hit the power button, those lights go dim, and then the rest of the lights and the channel display, everything else was just kind of, yeah. Well, what was causing that was the switch. Just dirty contacts. This radio probably hasn't been used for Lord knows how long, so Lord knows the last time this switch was actually switched. Just oxidized contacts. Now these you can actually take apart, just take off the Phillips screws there, the switch pops out, and you can see these 2 little yellow pieces. They're actually just little like spring fingers that wrap around the outside. And then there's one on the other side. You can just pop those loose, take the little cover off of the switch, stick a piece of paper in there, and just run it back and through the switch contacts a couple times, polish the contacts up, put it back together, works fine now. So, yeah, if you ever have a radio that has one of these mechanical clocks in it, and you're having power problems, and you suspect it might be your power supply, one of the first things to check that little micro switch. It could very well be that's what your problem is. So let me, I need to get a laundry list together. Like I said, I need to go over this thing and see exactly what all needs to be done to it. Actually, let me, it's going to be a little hard doing this. I'm going to just flip it over, show you the underside. Let's get this can top so it doesn't flop around. Get popped back on there. Of course, I got all of this hoo-ha here to deal with. And my camera boom's in the way. Let me move up. Up and away. Yes, there's all kinds of dirt and stuff falling out of this thing. And packing peanut dust. And, there's actually the washer for the switch. Okay, so there you can see why the PLL circuit is a pain in the butt to work on. Yeah, see that? It's solid. So if you need to get to any components on that PLL board, you have to desolder all of the solder tabs here and try to pull that board up and out. You have to remember it's got a bunch of pass-throughs here, a bunch of pass-throughs coming in on this side, so yeah, it's just a pain in the butt to work on. Actually, the last one of these that I did work on, there was a huge hole cut in here. Someone had done a channel mod to that one, and instead of attacking it from the top side, they did it from the bottom side. And what they did was just cut a huge gaping hole in the bottom side here. So yeah, that wasn't very good. Some of the other stuff, I'm not sure. Maybe they just didn't have wire ties. There's just little pieces of black tape. Yeah, actually, it looks like that's all they did. They were using black tape as a wire tie. Because there's... Actually, that's right off of the power... Maybe that's powering their channel mod circuit. Actually, the bottom doesn't look bad. Other than, you know, they use pieces of tape for wire ties. That's, yeah, there's a... I don't know if you can see that. It's kind of around the corner there. There's a wire, and there's another piece of wire just bodged up, hanging up here off of the edge card, off of that little circuit board. That should be part of the channel mod. I didn't see that. What do we have going on down there? I don't know, though. If we look... So we have the 3-switch board down here, which has the CBPA, the noise blanker, and the power switch on it. This board down here, you can see all those cut circuit traces. The thing is, they all work. Maybe... I don't know, I'll have to check. That just doesn't look factory. I mean, it's common for factories to do modifications to a circuit board sometimes by cutting traces and adding, changing circuits, but that doesn't look factory done. It's just not quite that neat. But everything works. Well, I'm not sure about CBPA. I know the noise blanker works, and I know the power switch works. I'm not sure what the heck they got going on here. Yeah, I'm gonna have to check that out. But otherwise, the rest of the radio doesn't really look to be... It's got the normal factory bodge parts. That capacitor there, I'm not... That might be an add-on. As with that, like I say, well, actually I got the service manual right here. Well, I guess... let's see, gotta get my orientation of the picture right here. Yeah, that one and that one look like they may have been added. The problem with Sam's manuals is the photographs they'll have in these will usually be the first release of a radio. So, you know, like the first radio to hit the street. I guess back in the day, radio manufacturers sent stuff to Sam's. You know, they always got like the first version. So if there were any changes to a radio, it's usually not going to be in the Sam's manual. But yeah, I think that one's an add-on. Most of these other ones are factory, but this one and possibly this one, I think maybe add-ons, and that may be to do some of the broadbanding, because actually, yeah, this one is across. Yeah, that's the double-tuned transformer can. Actually, I'm just out of camera view. Right above this would be the double-tuned transformer can, which feeds into the pre-driver, which is right here, and then of course your driver and your final. So yeah, I think that might be part of their broadbanding, which the radio does broadband well. It goes out to about 28 megahertz. Well, actually, it might go over that a little bit. I haven't played with all the switch positions on that channel modification. Oh, yeah, and one other thing I forgot to mention. From the top side, there's actually supposed to be 2 relays. This doesn't have 2 relays on the top side. Someone has, I guess the relay went bad, and I see this a lot. people won't have the proper relay in these radios, and they'll bodge it in on the bottom side, because they don't have the proper one here. They can get a relay that will work, it just won't fit. the pins won't align, so they'll stick one, glue it in here and just run wires down. That works fine, as long as it works. There's really nothing. It may look a little messy, it's on the underside, but there's really nothing wrong with doing that. It works, gets the job done. So like I say, let me go over this thing. I need to contact the customer, see exactly what he wants to do. Now, he had mentioned about putting a frequency counter in this radio because he thought the clock didn't work. Like I say, actually, the clock does work. Seems to work fine. The only problem with putting a clock in this in place, or not putting a clock in it, putting a frequency counter in place of the clock is, that would be a lot of work. Some radios, the faceplates are fairly easy to modify. Yeah, this one not so much. The problem with this radio is this entire faceplate here is one solid piece of acrylic. And you don't make frequency counters, the little frequency counter modules, that small. And yeah, you'd almost have to try and get this plastic acrylic that's glued to the aluminum structure off, so I could then take this out either with a saw or on a milling machine and cut basically right on those blue lines, so I could make a new insert to stick in there. And even then, it's not going to look neat. You're going to have, two butted edges there then, to make a new window to stick in there. Like I say, I'd leave it as is. The clock actually works. And this is one of the better clocks. These clocks actually don't usually go bad. Let me just turn the radio here so you can actually see the backside. This is one of the clocks that usually do not have problems. There were two clock styles that were commonly used in radios. This one, and actually if you just hold on a second, I can actually go grab one of the other ones. Oh, let's see. The wonders of wireless microphones. I can walk out here to the shelf, and that's not the right style clock. That's actually the exact same thing I have sitting in there on the bench. That looks like that might be one. No, that's that style too. Here we go. Here's one out of a Madison. This is the kind that usually breaks. Okay, so this is the kind of clock that you will usually see has problems. What causes the fault in this one is there's a little, and it's actually repairable. You can get rebuild kits. Intech made these clocks, and if you look on eBay and clock, companies that sell clocks, like for projects and whatnot, they actually make rebuild kits for these things. The problem is the gear on the motor that comes out is kind of like a rubbery plastic, and it just deteriorates over the decades, and eventually all the teeth strip off of it. You can actually replace that. It's just a matter of popping this little rear aluminum cover off, changing two gears, put the cover back on, and the clock works fine. These did not have that problem. These did not have that plastic gear. No, I think it's actually brass in this one, all of it. Yeah, and it's direct drive. So you've got the motor with a shaft that comes out, and that directly drives with the cross shaft there. Where this other style clock here has a gear reduction, and that's where the problem is. It's the gear off of the motor that drives that reduction drive actually strips out. Like I say, the plastic, rubbery type plastic just deteriorates. So it's rare to see. Now, don't get me wrong, they can go bad. It's just 9 times out of 10, these will be fine, where the other ones, yeah, then when somebody says one of these doesn't work, yeah, it's a bad clock. So let me get to it here. Overall, it needs some help. I'm probably just going to, and he had mentioned about, my thoughts on the channel modification. Honestly, I think the way this was done, I'd probably leave. I'll replace the electrolytic capacitor on there when I recap it. But I'd probably leave it because it has a hole in the top cover. There's really nothing you can do for that. So, it gets you all lots of extra channels. This was done in I guess you could almost say, a better way than the normal switch mod. Somebody took their time doing it, rigging all of this stuff up. And it's kind of old school. And honestly, that's another thing that's kind of neat. It's, if nothing else, the nostalgia value of how the modification was done. You just don't see modifications done like this anymore. You'd see, like one of Mark's Channel King boards or something, microprocessor controlled. This was high-tech channel modification back in the days right here. So, in any case, let me get going. I'll be back, and we'll see what he wants done to it. Okay, so I'm not done with, but I'm fair way through recapping the radio. So contacted a customer, explained to him what I had found. Power supply was okay, nothing was broken. It was just the dirty contacts and the micro switch there on the clock. Explained the channel modification because he just wanted my opinion, what to do. I'm just going to recommend leaving it as is. It's an old school radio with an old school mod. It wasn't hacked at. There's no cut circuit traces down here. They did, went above and beyond what honestly the average person would do when they do a channel modification with the diode board and the IC here. And it pretty much, it looks like, I think this radio probably gets all possible channels. I won't know till I actually map out the channels, but I just looking at the way they have everything hooked up here, I think it will probably get all channels. So, I still need to remove some modifications. That's why this cap and this cap haven't been changed, because they're going to be going bye-bye soon. And I'm still recapping. So I want to get all of the caps that I'm going to change replaced first. Then I'll go in and start removing stuff. Best to work on stuff like that. Don't just go looking at a radio, see 20 things that need to be removed, maybe a repair, and replacing electrolytic capacitors, and just do it all in one fell swoop without ever powering the radio back up, especially if you're new at this. If you don't have a lot of experience, it's best to start with one thing at a time. Remove a mod, see does the radio still work. If you're doing the caps, change the caps, or maybe only change half of them. Power the radio back up and make sure it still works. I see quite a few radios, because I do have people that recap their own radios and then send them to me to do other repair work to them and do the alignments. Don't ever take as written gospel what's printed on these circuit boards. Not just specifically this radio, any radio. It's very common to find the silk screening, the print, the little small type on the board. They'll have the polarity markings for electrolytic capacitors. Don't be surprised if it's wrong. I'm not talking about it's all wrong, but one or two capacitors may be backwards, the way they're labeled on the board. Well, if you don't pay attention to how you took the original capacitor out of the radio, and you then look at the circuit board and install it the way that the board has printed on there, it's in backwards. The cap will either blow up, you're not very likely unless it's like a filter cap on a power supply board, one of the big filter caps. The smaller ones, usually, it'll just kill a circuit, like your audio circuit, synthesizer circuit. It'll, kill a certain portion of the circuit. So, like I say, try and take it in small steps. Once you get better at stuff, now, when I recap a radio, I just recap it and just move on. I don't even need to turn it on. I feel pretty safe that I've done everything right. And even if I didn't, I have the ability here to actually diagnose what I might have done to it. But in any case, so I had said about these radios are a pain in the butt to work on. For starters, just lots of wires. Wires on the bottom, and you got to be careful with all of that wiring on the bottom, because you're going to be in there with, if you have a desoldering tool, you're going to be in there with your desoldering tool. At the very least, you're going to be in there with a soldering iron, and that's something I see all the time. wires with melt marks, because people come in here, you know, they're working on a part down here, not paying attention to, let's say, this wire right here, and they lay their soldering iron down sideways against it and melt right through the wires. So you just be aware of your surroundings inside the radio. The big thing that makes this the most pain in the butt to work on is this PLL module. Like I showed, the bottom side of the board, there's just no access. Short of destructive methods like the last one of these I worked on where somebody cut a huge gaping hole in the underside. Bad idea. They're using the copper foil on the bottom of the board for starters for some extra shielding, and if you cut a huge gaping hole in the underside of the board, well, now it's open. There's no more shielding down there. So to remove this one, I desoldered all the tabs that stick through the can on the bottom side. So they stick down through and they're twisted, and then they solder them. So when you desolder those, you're going to need to straighten them out. If you don't have, you can get cheap ones. These are better quality pair, but get yourself some duckbill pliers. They're really wide jaws, you know, compared to your normal needle nose pliers. I like these for straightening out those tabs, because the slots in the circuit board sometimes can be very tight. It's not so much getting it out, but getting it pushed back down in. Those tabs need to be really straight. These things are great for that. You can just grab a hold of them, give them a jiggle, it'll have it flattened right back out. So I got those desoldered. Now even once they're desoldered, I still can't get the can out. You can only pick it up a little bit, and that's all the farther it's going to go. That's because it has all the wires. There's this kind of like an edge card that sticks out the side that all of these wires are attached to. You've got pass-through capacitors here, with all these wires in the back. You've got all these pass-throughs along this side, which is where your frequencies are actually coming out of this module. Easiest way I found, and then to make matters worse, this one has extra wires. You know, there's an extra wire. This ribbon cable, that's part of the channel mod. That wasn't originally there. There's extra wire bodged on here, which I don't know why they... I'm going to have to look at that one. That goes over... Yeah, that makes no sense. I got to check that. And then there was another wire running down from that edge that sticks out here down to the underside of the board, so I had to unsolder that. Easiest way to get this out is usually, especially if it doesn't have any extra channel modifications like this, just desolder everything off of this side. You can usually leave all the wires along the back side and all the wires along this side. Once you get these undone, like I've already done here, so this coax cable's unhooked, this blue wire, and this coax cable. Again, if you're not familiar with the radio, make yourself a little drawing or take a picture of what hooks up where before you go taking anything off. That way when you put it back in, you can make sure you hook it up correctly. And once all that's disconnected, I can then at least get the board twisted up that far. That's all the farther I can really get it out. And actually, there's that wire right... Not to get in the view of the camera here. This wire here actually goes down. That's part of the channel modification to a wire on the underside of the board. But now, at least gives me room to get down in here now with the desoldering iron, because, yes, there are electrolytic capacitors in here. You know, there's one there, one there, one there. I think there's only 3, I think, inside this can. But yeah, so that's the only way really to get to them, like I say, without being destructive and cutting holes in the bottom. So I just thought I'd show that. Like I say, be careful when you're working on stuff like this. Another thing to watch out for, if it has modifications, usually factory soldered on stuff's going to be fine. They'll have wrapped it around these terminals or whatnot. Watch out when you're dealing with anything that was a modification somebody installed in. You don't know what their, how should we say, soldering skills are. So now everything this person did seems to be very well done. You know, be a little bit neater maybe, but it works fine. The wires, I can tug on the wire. It's not, you know, it's not coming off of there. Very frequently I'll see stuff that's been modified. You just touch a wire and they break off. They did a very poor job of soldering stuff on. So be careful when you're working on stuff like this, especially if it has like this ribbon cables with lots of extra wires. The last thing you want to do is go move something and all the wires start popping off. And like I said, you didn't take a picture or make a drawing, so you don't, you know, now you have no idea where anything went. So let me get it recapping this module. Then the only other thing I had to do are pop this small board off the back, because there's a bunch of electrolytic capacitors on there for the, that's part of the audio circuit hanging off the back here. and I think there's two. There's one I think across the speaker and one across one of the switches up here. But and then I'll let's see. I guess the only other thing I got to do then is, like I say, I'll vacuum it out and dust it off. Then remove some of this hocus pocus. Actually, I just need to pull the schematic out and see what some of this hocus pocus here is actually doing, what they were trying to achieve, and get all that junk removed. Is that? Oh, that's factory. Yeah, it's always an adventure trying to figure out what you need to undo, what's been done to a radio. Yeah, that sometimes can be hair pulling out fun. So I'll be back. Okay, so I think I've got pretty much everything done now, with the exception of putting the covers back on it. I may add just a little short section on the end showing with the top cover on, because, like I say, it's got a hole butchered in the top for this switch mod down here. So all the caps have been changed, took out all the heat sinks, put in fresh heat sink compound, cap job, cleaned it up on the inside. Still got to finish cleaning up the exterior. Like I say, I haven't put the cabinet, top, bottom, and sides on yet. Good working radio, though. The clock, for starters, you can actually see it. Oh my God, was there ever a lot of schmutz on that? Wow. There was some dirt on the inside of the lens, but man, the number dials were just horribly nasty. That's where most of that black was actually. It was stuck to the number wheels. Got all that cleaned off, and surprisingly, you can see the clock again. So you installed LED lights. So all of the lights have been changed over to LED. In case you're not familiar with how these work with this rotary clock, and yes, we'll get to the little box on top in a minute, but the clocks on these, they're an alarm also, so you can set it so the alarm will turn on the little internal buzzer, which is nothing more than a little metal strip that vibrates up and down, or it'll turn the radio on, or just the radio. So you can have, I'm trying to think here, what is it? The alarm buzzer and the radio, and either just the radio or just the buzzer. Shoot, I can't even remember. It's not like I ever actually, it's not like I have one of these sitting beside my bed. But, so there's actually a 4-position rotary switch here. So if you turn it, well, let's turn the radio off. And if you but you'll notice the illumination for the clock is still illuminated. That's because this is in the on position. If you switch to the off position, that kills everything. So no more lights to the clock either. But the radio will not turn on. That literally disconnects everything. So power supply is not doing anything. If you turn it on, that enables, and you can probably just see it flick there. You can see that lever moving up and down right there. That's what's actually actuating that little micro switch right there, which I had to clean because the contacts in that were dirty. That now basically connects the power supply in the circuit. And then you can turn your radio on and off. Now, if you want to use the alarm, let's see, let's just go down to alarm. So full rotation that direction. If I turn the radio on, there's nothing. And then I'll spin this, and if you watch while I'm turning this, now this, you can use this to set the clock. If you push in and rotate, that adjusts the clock. And then if you just leave it out, you don't push in on it and turn it, that adjusts the little the alarm wheel on there. So if we turn that, eventually we get around here close to 9, it'll trip on. Okay, so yeah, in the alarm position, it turns the buzzer on, and as long as you have this power switch here turned on, that'll also turn on your radio. If it's in the auto position, okay, that's why I couldn't remember for sure. If you put it in the auto position, it does not turn the alarm buzzer on, but when the alarm trips, it'll turn your radio on again, as long as you have the power switch turned on over here. So, let's see what else. The module, because this has that rotary switch mod, like I say, that'll have channels in banks. You'll get some new channels here, and they're just kind of scattered all over the map. without a channel map, you kind of need a frequency counter. So the customer asked, could I do something for a frequency counter? And we can see it's flipping around here a little bit. That's because I just actually turned the radio on just here a very short time ago. And radios have a little bit of frequency drift. So until they first, basically in this one, until that PLL module, everything in there warms up. It doesn't take long, just a couple minutes, it stabilizes. But yeah, and you'll see that with frequency counters, they'll jitter. Once they get to that, basically what I call the cliff point, it's either, is it 27.185 or is it 27.1849? Well, and this, the frequency, or the little module that I used here for the frequency counter, I did some modifications to it. You can get these things on eBay, they're cheap. But I did a little bit of modification to this when I added to the outside of the box so you can actually change the display here. If you hit this little button, what it does is it shifts the entire frequency counter over to the left by basically one significant digit, or the tens megahertz. Because you'll notice it no longer says 27.185, it says 7.185.00. So this now has 10 hertz resolution. That gives you basically 10 hertz resolution on a... there's somebody actually breaking Squelch there. Gives you... yeah, kind of weak. That's the local mill. But like I say, it gives you the resolution is selectable. So just hit the little button. It'll switch back to reading tens of megahertz, but it ends in 100 hertz. And if you hit the little button again, it'll switch over to where the most significant digit is actually just the megahertz position, but your least significant digit is then the 10 hertz position. And you can see it's bouncing between, it's that 10 hertz, it's just bouncing between. That's why when we're on the 27, reading the most significant digit in the tens of megahertz, it's bouncing around there. And you're going to see that with frequency counter. And if you put this thing on the tens hertz resolution, good luck getting that thing dead nuts on a frequency, because that's very, as far as a CB radio is concerned, 10 hertz resolution is really touchy. That's really fine. So just trying to get that tuned in with the clarifier, it just the slightest, you just breathe on the clarifier, and you go up a digit or down a digit, you're just barely there. See, up there, well, it's almost, yeah. So, like I say, but that gives you, like I say, very good resolution on the frequency counter. So we'll just leave that on, and that's probably what, the customer is going to use. The other thing is, it's the one thing I absolutely hate about these little modules. This display is composed of two 3-section LEDs. So this little module on the left has 3 digits, and the little module on the right has 3 digits. The problem is they're PWM driven, or pulse width modulation, and PWM driven LED displays like this are notoriously noisy. I mean, just the amount of digital noise that comes out of these things is, it's like, well, actually, fingernails down a chalkboard don't bother me, but for those of you that does bother, that's about it's nerve-wracking, the amount of noise that comes out of these things. And it's hard to get that filtered out. So, I got the majority of it filtered out. But, and I don't know if you can hear it, with the volume down the whole way, there is a little bit of a buzz there. Now, when I just first hooked this thing up, just when I was first setting it up, I attached the power line directly to the power, basically the power supply in the radio. Oh my God, it was like having the volume set at like probably somewhere between 1/8 and 1/4. It was loud, just that bzzz, and the buzz tone changes a little bit depending which segments are illuminated, because the more, more or less, so it's changing, and it's just, like I said, that noise is just, it's nerve-wracking. So lots of extra filtering with both ceramic and electrolytic capacitors. Basically, you have to build yourself some filter networks. But like I say, getting that last little tiny bit of buzz out of the audio is, I'm not going to say it's impossible, but it would get really expensive just sitting here playing around with filter circuits all day, trying to come up with the ideal circuit. And the problem is that ideal circuit can vary from radio to radio. One radio might be more susceptible to the other, to different frequency ranges. So yeah, the easiest thing to do is if that tiny bit of noise, and like I say, it's mainly only noticeable when the volume's turned down the whole way. Now when you turn the squelch up, it's gone. So when you're using the squelch, it's not like you're going to have to listen to that buzz while the radio's in squelch mode. So that's an advantage. But if you do want to get completely rid of that noise, I made it really simple. On the back of the little box, there's a toggle switch. Flip the toggle switch, it turns the counter off. No counter, no buzz. So yeah, simple solution to that problem. So let's turn the volume up here a little bit. And one thing I really like about this radio is it does have a very effective, like I say, this is a UPD 858 chassis. It is the variant. It's not the very popular one, but it is a Uniden UPD 858 chassis. But one thing I like about this, has a very effective noise blanker, and this radio has something that I think all radios should have, is a tone control. Now this isn't a variable tone control, it's part of the squelch control. It's a push-pull knob. Basically it's a high cut filter. In modern radios, actually, like the President Lincoln back there, and a lot of your modern radios, they'll have what they call a high cut filter. That's basically what this is. Like I say, it's a non-adjustable. All it is a capacitor in there that's added into circuit to filter off the high frequency audio. But between that and the noise, well, we'll start with nothing. No noise blanker and no tone control. Actually, the noise blanker is actually the ANL noise blanker. But we'll start out with nothing and then add the blanker and then pull out on for the tone, and it really quiets it up. Between those two, it can take a surprising amount of noise out of the receive in one of these things. So let's turn it off here. Get the camera repositioned so you can see the inside here. Now, probably the first and most noticeable thing is, what happened to the little board that was over here? The board looks different. Well, there's the board right there. Let me just slide this counter. And what I'll do for this is I'll just send some double-sided, or the Velcro tape along to the customer. So if he wants to stick this on the top of the radio, but not, no holes drilled, not that it matters because it already has a huge gaping hole in it, but I'll give him some Velcro tape. So if he wants to, he can just stick this. He can either just set it on there, or he can, kind of semi-permanently attach it with some Velcro tape to the top of the radio. But yeah, this little module right here, wasn't really sure. I hadn't looked at it that hard before what it was doing. Not much. Honestly, they have had a resistor in series with the power line. There were 3 wires going to this. One went to ground, one went to the DC power source, basically straight off the power supply, and the other one fed to Clarifier. And yeah, once I got this board pulled up, because of course I couldn't see the underside, it was epoxied down to the lid of the PLL can. Once I actually popped this thing loose, broke it off basically, I got to the underside and I was like, well, hell, it's not even attached. So it looks like, and I'm just best guess here, I'm going to say this was a channel modification at one time. There were 2 holes drilled in the back of the radio previously. I'm using one of them because it's an existing hole, so might as well use an existing hole. We don't like making holes. That actually runs out for the frequency counter. But yeah, it had two holes, so it obviously had some modifications at some point in time. But the channel modification that it has now is this one with this rotary switch. So, well, I think that's what this was. This was basically a poor man's power supply circuit, just a dropping circuit. But this is actually a LM, what is it, a 111, I think? Yeah, it's a LM111, which is a comparator IC. I think they were probably using this as part of the previous channel mod. So a comparator, well, I mean, you can use them for all kinds of stuff, from switching amplifiers to just sensing sensing states of, in this case, what I think they did was, they were probably sensing the state of 2 different switches, using this to not have to basically drill a 3rd hole. So depending on the switch positions, depending on which inputs on the comparator IC were high or low, it would then set the output high or low. So yeah, I think this was part of a previous channel mod. They just left it in there and continued to use the power supply, basically part of it, to feed the clarifier. So yeah, we didn't need this anymore, so yeah, it went away. But I did still want to lower the voltage, because the clarifier modification they had in this, man, they took the long way around to unlocking a clarifier. Unlocking a clarifier in one of these things is actually pretty simple. It's, let's see, I think you pull a diode, pull one lead of a resistor, supply voltage to that, and yeah, that's pretty much it. It's a very simple clarifier to unlock. There are a lot of parts pulled out of this thing, and it's been completely rewired. The clarifier itself, all three wires, not just one wire, all three of them were pulled off of the main board and run to different locations now. So they completely rewired the clarifier circuit. I think they did that in an attempt to get more slide out of it, which they did. And I can actually power the radio up here. Okay, and actually demonstrate that. So that's what the clarifier centered. I'll turn it full clockwise rotation, and you can see we get to 27.19, so it's got 5K clockwise, and to 27.1792, so it's got about 5.2 kilohertz of slide counterclockwise. So it's got, what, 10.2K worth of slide. And I think that might have been what they were doing with their clarifier mod. The easiest thing for them would have been to do would have been just do the normal clarifier modification, the resistor and the diode. You know, remove the resistor or remove the diode, volt the supply voltage, continuous voltage to that resistor instead of switched receive and transmit, and then just change out the varactor diodes for a varactor diode that has more capacitance range over the voltage. They did it by just increasing the voltage some, so I wanted to do that as well. I wanted to leave their modification in. It works. It gets, what, 10.2K worth of slide, so, and it works fine. There's really nothing wrong with the way they did it. But I wanted to get rid of this thing, so I installed a much more modern power supply board in here, basically for two reasons. First off, for the clarifier, it makes it adjustable. It's got a little trimmer resistor down on here so you can adjust the voltage. I've got the voltage adjusted. The second and the main reason is this board right here is removing, God, probably 95% of that digital buzz caused by this little frequency counter module. I've got extra large fill. Actually, this cap I think would originally be like a 1K, and there was no cap here. So I've increased the value of this one and installed an extra filter capacitor here at the input of it, and that helps to keep that digital noise from coming back through the board and then feeding back into basically the entire radio and leaching into the audio circuit on this thing. So that's the main reason I installed this. Usually anytime I use one of those little frequency counter modules, I've either got to use one of these or just make my own voltage regulator circuit to accomplish the same thing. So that's been done. You can see radio is cleaner on the inside now. I got all the wires tied up. All of the, like I said, all the lights have been changed. Fresh heatsink compound. One word of caution: if you ever work on this exact model of radio right here, with actually most of the radios that I know of that use this variant of this UPD 858 chassis, be careful if you're going to remove the heat sinks to apply new heatsink compound. When you take this heatsink out right here that comes up underneath of the clock and loops around a little bit, all of the screws are not on the top. So, you'll have to take the screws out of the PLL board, or not the PLL board, try that again, out of the SWR bridge board, voltage regulator. You take the screw out of the driver and the final, and there's another voltage regulator screwed up in on the front side of it here. You take all those out, and you would think, well, I just take out then the screws that go down through the heatsink plate here into the chassis, and if you go and grab this thing and try and pull it out, you're going to break the circuit board. This has a couple extra screws that come up from the underside, so let's see if we can get zoomed in or not here so you can actually see. Perfect. So right there, you can actually see the tip of the screw coming through, right there. So they have a little tab, it's notched out, where on this, the main heatsink plate bends. Instead of bending that direction for the mounting screws here, they bent the tab this way, and that's what the final transistor, and the same for the driver mount too. But on the bottom side of the circuit board, there's a Phillips screw that comes up through it right there. So make sure that you take those two screws out, because if you take everything else out and you try and pull this board out and you think, well, because it's a tight squeeze. Not going to lie to you. Getting one of these things out is a little bit challenging. Fortunately, on these radios, if you take the faceplate off, you take a screw out of each corner in the top, two in from the front on each side. There's a Phillips screw on the side of the radio. You can't miss it. There's actually a little slot. You can pivot the face of this radio forward only about that much, but that's enough. You tilt it forward, then you can get this up out of there. But it's still, you got the driver and the final laying down, so it's kind of a chore getting it up out of there. And if you don't realize those screws are there, you'll be jiggling, going, why isn't this thing coming out? And you go, Urgh! And yeah, you snap the board off. So just word of caution. I guess that's about it. Like I say, nice working radio. I'll get the cover stuck back on it so you can see it once it's all together. And yeah, I don't know, I'm going to have to maybe find another knob for this thing, because I had to pull the tape. Somebody had masking tape around it to put numbers on, I guess, for like switch positions, and they got a little pointer again with this tape to the top cover. I hate masking tape. Whatever they use for glue, and if somebody knows, please let me know. Just not me, just the rest of the world. This glue, when it dries out like this, you can't get that residue off. As of yet, I have not found anything that will dissolve that glue and not dissolve what it's stuck to. So like this knob or something. I mean, I got stuff that'll take the glue residue off once it gets dried and hard, but the problem is it's so... it's such an aggressive solvent that it'll also melt the knob. Well, obviously I don't want to melt the knob, or in the case of the top cover, I don't want to take the paint off or the plastic coating on it. So yeah, I'll probably come up with a better knob or something. But yeah, it is what it is. Like I say, the switch mod works good though. And like I say, especially, turn the radio back on, since we have, let me just get the camera repositioned too. Since we have the frequency counter module, now when we go into those extra positions, we don't have to look over at a paper that we have all the channels written down on and what position, what they are. You just flip the switch, and then you can just turn the channel selector to get to whatever channel you want to. So there's 28035. I don't even know what the range is on this thing actually. Might be, I'm assuming that's probably about as high as it's going to go right there, 28045. I can't see it going any higher. I know it does go lower. Let's actually start out on one. Okay, there's 26605. 565. 365. What was the other one? That's 765. So it looks like probably 26365 is probably the lowest. Lowest it'll go up to 28, whatever I just had there, 28045, I think, somewhere around there. That sounds about right for one of these rotary switch mods on a UPD 858 PLL. So let me get her reassembled the rest of the way, and you can see what it looks like complete. Okay, so there she is all back together. I got lucky. The tape that was on the top cover there, actually with a little bit of a lighter fluid and a scrub brush, I was able to scrub it off. So it hadn't dried out and become fossilized yet. As long as it's still a little bit juicy, a little bit gummy, it comes off really easy. But yeah, like I say, once this masking tape residue, like on the knob here, it's dry. That's just, brittle, dry. So yeah, I just replaced the knob, stuck on a new, actually it's new old stock. I got a few hundred of those things. They're instrument knobs, but nice little knob with an aluminum cap, stuck that on there. It's a little bit smaller, so yeah, it doesn't look quite as bad considering it had that. That's what it looked like before on the top of the radio, and they had a piece of masking tape here with a little pointer coming up, and then they had another piece of tape here with another arrow pointing in. So yeah, all that's gone. Like I say, now he's got the frequency counter. If he wants it, he can just, turn it on and off. Depending what resolution he wants on the counter, hit the button, and then to change bands, you just rotate through and he'll be good to go. So the covers were actually in pretty good condition. They had a few scratches. I got those cleaned up, and the scratches are all basically filled in now, so you can't really see them. Only real problem is it looks like I don't think the radio got dropped is hit, because this thing it's got thick sheet metal. It's not like the little bit later radios where the radios were built light. Yeah, the sheet metal in this thing's pretty heavy duty. So I don't think the radio got dropped. If it did, it didn't get dropped very far, but there's the front of the wood end right here. I mean, they're plywood and veneered, but it's kind of smushed right on the corner here. But looking at it head on, you'd never even really know. Even from the side, it's only affects back about that far. But yeah, there is a little bit of some type of impact damage there. But the cover, like I say, cleaned up surprisingly well. Still got a nice sheen to it. Got all the glue off of there. And good working looking radio now. So get this thing boxed up and be ready to send back to your customer.